Review thermodynamics second law statements. 所以热力学第二定律。One, heat flow naturally goes from high temperature to low temperature. Two, efficiency of a heat engine is always less than efficiency of an ideal engine, such as Carnot engine. So E is efficiency, 效率。Carnot is the engine process type. In Chinese, 这是内燃机的一种过程，燃烧的一种过程。内燃机燃烧。Number three, heat input is always larger than the work produced. So you may have 100 joule of heat input, but 100 joule can only produce less than 100 joule of work. Heat engine would not be able to give you transfer all the heat input to 100% to the work. Four, in the refrigerator or air conditioner, the heat that you can draw from the cold temperature area will always be less than the heat that you need to give it to the hotter area. Number five, the entropy is S. Sun in Chinese, this is called sun. So delta, right? Entropy change is always larger than zero, meaning the final entropy is always larger than initial entropy for an isolated system. So the increase for the cold temperature, this one here, will always be larger than the reduction from the hotter area. Okay, for an isolated system. So you have two portions, one's hot, one's cold. So the colder area will always receive more, but the hotter area will give a little less. Six, delta S is always larger than zero for the real system, meaning that it's not isolated. So now you have the system, but you also have the environment. In the isolated system, you are totally isolated. So environment has no effect on you. 在这个孤立的系统，第五个叫孤立系统，环境对你不会有任何影响，因为你是孤立的。In the real system, the change in the system and the change on the environment, when you add them together, they always has to be larger than zero. So all of these are second law statement. Right? Number seven, the system always become more disordered. So it's always become more chaotic. Chaotic in Chinese means 混乱. Always become more chaotic. Number eight, not all the energy can be converted to work naturally. For example, if you drop a baseball from the top, before it hit the ground, it can still do work. But once you hit the ground, now your kinetic energy will transfer at least some of them to thermal energy. And the one that transfers thermal energy, you cannot use it to do work naturally anymore. Number nine, from the statistical interpretation, 统计学的 statistical in Chinese means 统计. So the one that occurs the most often is the one that has the most entropy or the most randomness. 所以最混乱的那个 state 那个 state 是最容易发生的。 Review for heat engine. QH is the heat input at the hot temperature. QL is the heat output at the colder temperature area. W is what you are looking for in the heat engine. So heat engine example, like a car's engine. In Chinese, heat engine is a 热机. So efficiency is defined as desired output by the input. So the input here is the heat coming from the hotter area that you have to provide. So if you provide 100 joule, you may only get 30 joule for the work, and then you will lose some in the exhaust area. So this is where the car's exhaust pipe. In ideal case, like a Carnot engine, then you can replace this QH by the TH, the QL by the TL. And it's considered a reversible engine. So meaning you can go one way, you can come back the other way. So then your efficiency will be calculated as this ratio here, which is roughly about 23% only. So that is the best case for a heat engine. Review for refrigerator. So this is 冰箱, refrigerator in Chinese. So QH is equal to QL plus W. So inside the refrigerator, you try to make it colder. So you want to draw the heat from the food and put it into this refrigerators out in the back. And your compressor has to work hard using electricity. Now the kitchen gets dumps of this hotter air. So your input is your W, which is a compressor. And your desired output is what's the heat that you can draw from the food. So QH is equal to QL plus W. And the coefficient of performance, COP, is defined as similar to the heat engine, input and the desired output. So that's QL divided by W. Review Carnot cycle. So Carnot cycle cannot be just used inside a car's engine. So this is not real. And it's reversible, but real system is always irreversible. 所以这个 in Chinese 这个 Carnot 的这个 cycle 是没有办法直接用在汽车里的内燃机。Okay, Carnot cycle is going from A to B. You can see the volume is increasing. So VB is larger than VA. So then the delta V from A to B is equal to VB minus VA is larger than 0. So it's expansion. And this is the high temperature. So all this here is at the same temperature, every single point. It's all at the same temperature. So it's called isothermal. So isothermal expansion, B to C, is adiabatic, meaning there's no heat. So I'm not drawing any Q here in this from B to C. There's no Q here. So adiabatics means your Q from B to C is equal to 0. So there's no heat exchange. And then C to D, you can see the VC is right there. And then VD is right there. So it's compression again, because VD is less than VC. In Chinese, this means 压缩. So C to D, in Chinese, this is 压缩. And then finally, D, go back to A now. which is adiabatic compression. So again, there's no Q exchange right here. And in this process from C to D, it's along the line of TL. Remember, TL and TH, this isothermal line, they behave like this. And if this is Y and this is X, XY, it's equal to a constant. So those are from your geometry lesson. So Carnot cycle is equal to 2 compression plus 2 expansion plus 2 compression. Okay, so that's it for the review. Thank you for watching.